any group at axial position is unstable, but in equatorial position is more stable. Any group. It is the chemistry of cyclohexanes. So welcome to the first class of this series. In this series, we will discuss some important questions that may come in the next JEE Mains exam, which is about to be held on 8th September. So we will start with organic chemistry, and on the first class we will discuss a very basic part of organic chemistry, which is a general organic chemistry. So the first question that we are going to encounter is this one. So what does it say? It said that the number of sp2 sigma bonds in the compounds given below is. That means this compound has how many sp2 sigma bond that we need to figure out. So before we go into that problem, we first discuss what is a sp2 sigma bond. Now there is three types of carbon and carbon bond. There is single bond, there is 1 sigma and 0 pi bond. Another one is carbon-carbon double bond. Whereas in this case the carbon is sp3 hybridized, both the carbon. In this case the carbon is sp2 hybridized, and here is 1 sigma bond and 2 pi bond. And there is another third option, which is this one, and the carbon is sp hybridized. There is 1 sigma bond and 2 pi bond. There is a small mistake. This one is actually 1 pi bond and 1 sigma bond. So this is basically three types of carbon. Now we have clearly mentioned that if two carbon has double bond in between them, then the carbon will be sp2 hybridized. Hence we can clearly see that this carbon, this one, this one, this one, and this one, these 6 are the sp2 carbon atoms. So we just need to figure out how many sigma bonds are there. So let's draw the structure. So this is the structure. We have seen that this carbon is sp2, this carbon sp2, this carbon, this carbon. We will leave this part for later. So these two sp2 carbon, we also said that if there is a double bond, there will be two type of bond. One is sigma and another one is pi. Hence here is 1 sigma, as the questions clearly mention how many sigma bonds are there. So here is 1 sigma, here is another sigma, and in the same case here is another sigma. So you can say that there is 3 sigma bonds, but here most of the people will be wrong. Actually what happened, this carbon is sp2, this carbon is sp2. So if we write down this is sp2, is both are sp2 carbons, and also these two are also sp2 carbon. Hence if this bond is a sigma bond between two sp2 carbon, and this bond also a sigma bond between two sp2 carbon, this bond is also a sigma bond between two sp2 carbons. In this case we omitted this bond, so this bond is the extra sigma bond that is formed between these two sp2 carbons. Hence we found here there is 3 sigma and the extra sigma is out there. So the correct answer will be C. So there will be a total of 4 sigma bonds in this carbon. So how this problem will be done? So if we have the clear-cut knowledge about the sigma bond and the pi bond formation and the hybridization of the carbons, we can easily solve it. Just you have to keep in mind that these two is also sigma bonds, and this will be another sigma bond that we initially omitted. So come to the next problem then. So this is the second problem that we can write question number 2. But it said that which is the following rings is highly strained. Now we all know if there is a carbon-carbon bond, the lowest angle between a carbon and carbon is 109 degree 20 minutes, which is for sp3 hybridization. This is the lowest angle. But in general, if it is a 6-member ring, the angle for a 6-member ring, the angle generally lies around 120 degree. But for a 4-member ring, the angle becomes almost of 90 degree. So the minimum angle can be between a carbon and carbon is 109 degree and 28 minutes, whereas in a 4-member ring the angle becomes almost 90 degrees. So lesser the number of carbon atom in ring, higher will be the strain. That means if the ring contains 4 or less carbon atom, the ring will be strained. If the ring contains 5, 6 or 7 carbon or any other atoms, then the ring will be somewhat stable. Hence we can always see that this one has a 6-member ring, this is a 5-member ring, and this one is a 4-member ring. So this will be the most highly strained. That means if the question is asked differently, that which of the 4 options will have the lowest number or the lowest stability, then C will be the lowest stability or highest strained. Lowest stability, highest strained. So this one was a simple problem. I hope you all have understood it. So let's go to the next problem. This problem is also not very tricky. The question was asked that which of the following will be the most stable. Now we know that these are all conjugated systems. So more the conjugation, more will be the stability. Here, if we can see, in this case, there is a conjugation like this. This one can move up to there and this one can move up to there. So there is a conjugation in 1, 2, 3, 4, 5, 6, 7, 8. Total 8 carbon is involved in the conjugation system. In this case, there is 1, 2, 3, 4, 5 and 6. Here 6 carbon is involved. Hence we can obviously say A will be more stable than B. Similarly, in this case, this is an isolated double bond. This will not take part in conjugation, but this will, like that. So 1, 2, 3, 4, 5, 6. So 6. This is also 6-member or 6 carbon conjugation system. But now if we come into this is a somewhat complicated system and there is much more number of carbon involved, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And not only it has the maximum number of atoms involved in conjugation, but if we see it like this way, we can clearly say that this ring is an aromatic ring. So obviously the presence of this aromatic ring will make this bond most stable, or this compound most stable among all other compounds. None of this compound has a aromatic ring, but this one has an aromatic ring. So due to aromaticity, this ring or this compound will be the most stable, and hence the answer will be D. Coming to the next problem. This one. So it has say non-zero dipole moment. Now how dipole moment is generated? If there is a polar bond like this, this has a delta negative and this is a delta positive structure, there a moment occurs from the delta positive to the delta negative center. This is called dipole moment. But if there is this type of bond is exactly opposite to each other, and if they are exactly opposite to each other, their resultant force or resultant dipole moment will be 0. We express dipole moment with the symbol mu. So here it is that which compound has non-zero dipole moment. That means the compound dipole moment is non-zero. That means the compound has a net dipole moment. So let's start with this one. We can clearly see that there will be a dipole moment in this direction, and another in this direction. So 3 dipole moment of same magnitude, because the groups are same involved in each cases, the groups are same, hence the magnitude of the dipole moment will be same. In these cases, the 3 dipole moment occurs in 3 direction and the resultant dipole moment will be 0. This is the same case. 4 dipole moments occurs in exactly opposite to each other and the resultant will be 0. This is also the same case. The dipole of this bond and this bond will have a resultant dipole of this area, and this will have a resultant dipole of this area. So these 2 dipole will cancel each other and it will be 0. So you all got these 3 compounds have the dipole moment of 0. And this compound also looks like that this compound also has a 0 dipole moment, but which is not the case. Actually, this solid line means that both the bonds are in above the plane. That is, if we draw the carbon in this plane, we will clearly see that the OH will be above it. So the dipole moment occur in this type of direction and there will be a net dipole moment in these directions. Hence, in this compound, the dipole moment is non-zero. So the compounds having non-zero dipole moment will be option A, because it is a cis compound. If this compound was like this, somehow this OH is below and this OH is above, then it will have a 0 dipole moment due to cancelling out of each other. But in this case, the OH group are in the both same side, and hence it will have a non-zero dipole moment. So this compound will have a non-zero dipole moment, or you can say it, the cis compound has non-zero dipole moment. We have to remember this point also, that any cis compound in general cases have non-zero dipole moment. Trans compounds, on the other hand, in most of the cases possess 0 dipole moment. So this is the problem that we have right now, and there is one last problem, but the last problem will be a little bit of tricky, so let's go for it. Now it says that which of the following has the smallest heat of combustion. So what is the heat of combustion? When a compound is heated, it forms some other compounds. It completely gets burned or oxidized to form 2 different compounds. So if this compound, we can see from a reaction diagram that all reaction occurs like this. So if this one is X and this one is the product. So if X is more stable, the heat released will be the less. Means more stable the compound, least will be its heat of hydrogenation or combustion. So in this case, we just have to find out which one of these 4 will have the most stable configuration. The one with the most stable configuration will be the smallest one to have the smallest heat of combustion. Hence, we cannot determine this in this planar form. We have to convert them into our cyclohexane or the chair form of the cyclohexane. So how a chair form occurs? Basically like this. Then we know that axial and the equatorial bonds how axial and equatorial bonds are present out there. This one is the axial, that these sky color bonds are axial, and if we draw these pink color bonds are equatorial. But we know one thing, that any group at axial position is unstable, but in equatorial position is more stable. Any group. It is the chemistry of cyclohexanes chair form that any group present in the equatorial position will be more stable. So the biggest group is here is the CCH3 or the tertiary butyl group. So we will put the tertiary butyl group in all the cases. In all the cases, the tertiary butyl group is above the plane, and hence we will put it above the plane like that. This is the tertiary butyl group. Now, when it comes to the first compound, we can see that the CH3 group is adjacent to it, and it is also above the plane. Hence, the CH3 group will be in axial position, and the this CH3 group is below the plane, so this one will be at this position. So on the first compound there is one axial, or we can say this one will be at axial position. Now on the next structure, if we come to the next one, that is the option B, we'll see that CH3 was as usual in the equatorial position. This CH3 is in the axial, and this CH3 is also above the plane, hence it will be also in the same area. So there is two axial group, that is this one is axial, this one is axial. So obviously this will be more stable than this one. Come to this point, that is number 3. CH3 is below the plane, hence CH3 is with this, that is CH3 will be at equatorial position, and this CH3 is also below the plane. That means that this CH3 is also will be equatorial position. Hence there is no axial bond. We can say that in C there is no axial bond. No axial bond. And in this case, this will also be an axial. So we can find out that the C will be the most stable due to the presence of no axial bond. And hence, C will be the most stable, and we have already mentioned that the most stable compound will have the smallest rate of combustion. Hence, C will be the right answer. So basically, in this problem, you just need to remember the stereochemistry or the chemistry of the cyclohexane group, which we already have known or which we already have studied. So we know the chemistry of cyclohexane chair form, and we just draw the structures of all the 4 compounds, and we will easily get the answer, the correct answer. So this is the type of problem, or this is the type of questions that you can expect in the upcoming JEE Mains from this very basic part of the organic chemistry. This seems basic and very easy, but this is the building foundation of this organic chemistry. So you will have to study this part very carefully. Anyway, thank you for watching, and if you please like the video, if you have liked the video, please subscribe. So it will encourage me to post a new video every day. Thank you.